Hello everyone, welcome back to our channel. Today I want to share with you very important law that is called the Kirchhoff's laws. See, what is the Kirchhoff's laws? There are two Kirchhoff's laws. First one is the Kirchhoff's current law and second one is the Kirchhoff's voltage law. According to Kirchhoff's law, the statement is the algebraic sum of the currents at the junction is equals to 0. And you can call this is the junction rule also. It is based on the law of conservation of charge. Now we are taking one example here. Look, this is the current I1 coming through towards the junction, and this is the current I2. It is also coming towards the junction. And now you look here. This is the current I3. It is moving away from this one. So incoming current equals to outgoing current. I1 plus I2 equals to I3. When it comes, total current at the junction equals to 0. The algebraic sum of the currents at the junction is equals to 0. This is called the Kirchhoff's current law. And we are going to the one more problem based on this. Look here. We are taking, this is the current 4 amperes. And here also the current is 5 amperes. Here the current is 2 amperes. What is the current in this case? This is also you can take towards this. Here what are the incoming currents? 4 amperes, 2 amperes, 5 amperes, all are the incoming currents. So the current I equals to how much? 4 plus 2 plus 5. This is the 11 amperes. Like that we can find out the current. And one more example, look here. See, this is the 4 amperes. This is the 2 amperes. And here this is the 1 ampere. This is the 3 amperes. Find, like this current we have to find out. Here current is how much? Here how many junctions we should observe? See, this is one junction. Incoming current equals to how much? Both are incoming current. So 4 plus 2 how much? 6 amperes. When 6 amperes, here junction what happens? One current 1 ampere is going like this. So remaining how much is here? 5 amperes. At here how many currents are incoming? 5 and 3 are the incoming currents. So to final current I equals to 5 plus 3 amperes. So whatever the problem is there, we can solve this one with the help of the junction rule. This is the 8 amperes. Based on the Kirchhoff's law, we do few more problems. Look here, they have given one circuit. From this we can find out the I2 is how much, I3 is how much, and I4 is how much. Look here, how many junctions are there total? This is at junction A, this is at junction B, this is at junction C, and this is at junction D. See, first we can go through the at junction A. At junction A, what is the incoming current? Only one incoming current is there, that is the 15 amperes. So we can write it 15 amperes equals to I2 plus 8 amperes. See, they have given across the R5 how much current is there? 8 amperes. So we can write it I2 plus 8. From this I2 equals to 15 minus 8 is the 7 amperes. When we are looking this circuit, no, we are afraid and how to solve like that. But it's very easy. We should remember that at junction, incoming current equals to outgoing current. Here incoming current, they have given how many amperes? 15 amperes. Outgoing current, one of the current they have given 8 amperes. So we can follow the first rule and you can find out the I2. Then come to this point. Look here, when 8 amperes is coming at D, at junction D, incoming current equals to 8 amperes. Outgoing how many are there? 2 are there. So you can write it 8 equals to 5 amperes plus I4. From this I4 equals to how much? 3 amperes. Now we know the I2 and I4. Then come to at C. At C or B we can go first. At junction B, what are the incoming and what are the outgoing currents here? Here incoming current 3 amperes. This is the 3 amperes. This is the junction. This is the I2. I2 already you know that 7 amperes. Incoming currents are 7 and 3, both are incoming currents. Outgoing is clearly you know that I3. From this you can write it, I3 equals to 7 plus 3, 10 amperes. Like that at junction D, at junction C. See, incoming currents two are there. One is the I3, another one is the I4. Then we can find out the I1. Clearly I3 plus I4 equals to I1. Already you know I3 is how much? 10 amperes. Then I4 is how much? I4 is the 3 amperes. 10 plus 3, 13 amperes. Like that we can solve this type of problems. And one more problem I have written here. This is the one circuit they have given. Actually they have given first one switch is there. When we are closing this switch, how much current passing through this one? Already resistance they have given 2 ohms. And how much current we have to find out? I3 value we should find out. Here how many junctions are there you can consider. This is the junction. Here the potential is how much? V. Here clearly they have given potential is the 20 volts. And here the potential is 5 volts. When it is connecting to earth, what is the potential here? 0 volts. Now I am closing this switch and we can find out I3 is how much. Here also we can go through the Kirchhoff's first law only. According to that we can solve this one. Look. Here this is the incoming current. I am taking I1 equals to, and one more also incoming current. This is the I2. I1 plus I2. This is the I1 I am taking. Already I have written I1, and this is the I2. Outgoing current is the I3. But from the Ohm's law, what is the current formula? Current formula is potential by resistance. Here potential is 20 volts. 20 minus V. See how much potential difference is there? 20 minus V. Potential by resistance is giving the current. Resistance is how much? 2 ohms. Plus here how much potential is there? 5 minus V divided by what resistance is the 4 ohms equals to I3 is V minus 0. Why? It is giving to earth connection. We can treat earth potential is always 0. V minus 0 divided by 2. You solve this one, then you can get that. Then you are taking the common 2 and you should cancel here. 20 minus V, 5 minus V by 2 is equals to V. Then we do the, take the LCM. 40 minus 2V plus 5 minus V equals to 2V. After simplification, when we are sending, this is minus 3V is sending that side, that is the 5V equals to 45. Then V equals to 9 volts. This answer is not completed. Just now we found it. The potential at the junction is how much? 9 volts. But the question is I3 is how much? Now easily you can find it. I3 equals to potential difference. Anyway it is 9 minus 0. 9 by 2. Answer is 4.5 amperes. See, looking very big circuits, but easily you can solve when you know the Kirchhoff's first law applications. It is nothing but at junction incoming current equals to outgoing current. Otherwise you can say that at junction algebraic sum of the currents equals to 0. It is based on the law of conservation of charge also. Why? Incoming charge equals to outgoing charge. Problem we can go through the Kirchhoff's first law. Look here, they have given the junction like this. This is the 12 ohms. The potential is 15 volts. The question is find the current through the 12 volts. 12 ohms. How to find out this one? Here you can take one. This is the junction. We don't know about this potential. We should consider the V. From the Kirchhoff's law, we know that incoming current equals to outgoing current. From the figure, they have given that incoming currents are, they didn't given any incoming currents. Based on the potential only we can take it. See here 2 volts, here 3 volts and here 4 volts. And we should consider V. So current is flowing from high potential to low potential. You can consider all are outgoing currents. This is the I1. This is the I2. This is I3 and this is I4. Now we can find out the I1. We should write it. I1 equals to I2 plus I3 plus I4. The problem is we don't know about the potential here. First we focus on what is the potential here. For this, instead of I1, potential 15 minus V by resistance is the 12 ohm. Then I2 equals to how much? V minus 2 by 6 ohms. Then instead of I3, what we are writing? V minus 3 by how many ohms are there? 4 ohms are there. Plus through this one, V minus 4 by how many ohms are there? 8 ohms are there. After simplification, we are getting that potential is 68 by 15 volts. This is the V value. Once we know this potential difference, we can find out the current. I1 equals to 15 minus 68 by 15 divided by 12 ohms. After simplification, the answer is 157 by 180 amperes. Here also we applied the junction rule. At junction, incoming current equals to outgoing current. Incoming current, always current is flowing from high potential to low potential. So I1 is the incoming current, I2, I3 and I4 are the outgoing currents. After simplification, we can get it. Potential at the junction is 68 by 15 volts and the current through the 12 ohms is the 157 by 180 amperes. Now we can go through the one more application, that is the how to take the sign convention. Based on the current, we can take the sign convention. Look here. Here the point A, from A to B one resistor is there. If the current is flowing through the across the resistance, we can take it. This is VA minus IR equals to VB. Then second condition, you look here. This is moving like this. In this case, we can take it VA plus IR equals to VB. And this is the cell. If the current is flowing from, this is the direction of the current flowing from positive to negative charge. This is minus. If the current is flowing from here negative to positive charge, we can take it plus. Then in this case, capacitance also. This is one plate, this is another plate, and here capacitance is C. Here based on the flow of the charge. This is VA minus, here also from positive to negative. That's why potential is minus Q by C. Q by C is also giving the potential difference. Here also VA plus Q by C equals to VB. This is the potential. Thank you. Please subscribe my channel.